So good morning, classmates, and good morning, sir. We are group 6 and we are going to discuss experiment 2, voltage frequency and phase angle difference measurement. To start, the objectives of the experiment is to learn how to use the oscilloscope in the voltage frequency and phase angle measurements to study the relationship between the peak-to-peak value and effective value of an AC voltage. The third objective is to determine the frequency of a signal using the oscilloscope. And lastly is to determine the phase angle difference of two signals using the oscilloscope. Before starting, we are going to say the formulas that we have used throughout the experiment, which is for the effective voltage BRMS it is equal to the peak to peak voltage divided by 2 square root of 2, and the experimental phase difference is 360 times the frequency and times delta x. For the theoretical phase angle difference of the inductor, it is arctan 2 pi multiplied by the frequency and inductance all over the resistor. For the capacitor, it is equal to arctan of 1 all over 2 pi frequency times the capacitance and resistance.
Uh, so for the data of the voltage measurement, based on the procedure of the experiment, the data gathered are as follows. For the VRMS measured values, they were obtained by using the voltage probe, and the V peak to peak measured are obtained by using the grapher of and adjusting the cursors. And the VRMS measured in the 6 volts terminal was 6.0303 volts, while the V peak to peak measured is 17.056 volts. And the computed VRMS was obtained by using the formula of the V peak to peak all over 2 square root of 2. And for the 12 volts terminal, the VRMS measured is 11.9699 volts, and the V peak to peak measured is 33.991 volts. And the computed VRMS is equal to 12.0176 volts. Next slide. As for the frequency measurement, the measured frequency is 60 hertz, and the period of the measured frequency is 16.6667 hertz. And the computed frequency is 59.9999 hertz.
Okay, so in getting the phase angle difference measurement, so for every circuit configuration, both a voltage probe and a current probe is placed in the circuit to display the sine waves of the total current and total voltages across the circuit. So using the waveforms of the total current and total voltage, the time difference, which is delta x, is measured and recorded. So for the resistor and resistor in series configuration, the measured effective voltage is 220.1789 volts. Then the measured or the experimental phase difference is 359.99 degrees, or which is roughly around 360 degrees. In which case, the 360 degrees is also equivalent to 0 degrees. So in in comparison with the theoretical phase difference, it yields a near 0% error. So next slide. So for the resistor and inductor, the measured effective voltage is 219.7511 volts. The measured phase difference is 76.5288 degrees, and the theoretical phase difference is 76.2140 degrees. This yields a 0.4% error, which indicates nearly no error measurement. So next slide. So for the resistor capacitor series configuration, the measured effective voltage is 220.0622 volts. The measured phase difference is 60.9401 degrees and the theoretical phase difference is 60.5124 degrees, which yields a 0.7% error. So next slide, please. So for the inductor capacitor series configuration, the measured effective voltage is 219.8360 volts. The measured phase difference is 90.882 degrees and the theoretical phase difference is 90 degrees, which yields a 0.9% error. Slide.
Thank you, Titas. To sum up the experiment, we have related our observation and conclusion through the objective of the experiment. First, relating the values of VRMS based on the transformer's 6-volt and 12 volts output. The values measured using the probe that are precise since it indicates under ideally optimal condition. On the other hand, we have observed that first, the deviations or errors in values may have occurred from the way the graphs were measured in the software due to human error in tracing the graph. Yet, they are still close to the theoretical values and it may still be acknowledged since most of the components are readily available for use and there will still be a difference in some circumstances. Second, it is seen from the graph that two resistors, when connected in series, are in phase with respect to one another, which means no delay and consists of 0 degrees phase angle difference. Third, a phase difference of approximately 76 degrees is present between the connection of a resistor and inductor in series, and around 60 degrees of a resistor and capacitor, which both led to a time delay. Finally, a significant increase in the time delay and phase angle difference between an inductor and a capacitor. The said components are out of phase by approximately 90 degrees. As a result, they may cancel each other out since the peak of one is a negative peak of the other. And that is all we concluded. If you have any questions or clarification, please let us know. Thank you.
Thank you for listening. Have a nice day.